I just want you to observe the car going down the incline and what happens. Okay, it increases its speed. No. Don't follow the camera. Alright, when I press collect, it's going to start ticking, and then let it go. And you don't let it hit the motion detector, okay? So this is going to be considered... I'm ready. This is going to be considered the small incline, okay? Here we go. So listen. Oh, listen.
That was not.
Ah. Try again.
Somebody else do this.
Okay, you ready?
No, I'm sorry. Okay.
I'll be quiet now, I'm sorry. Okay, take 3.
Okay.
You did a great job.
Watching him. I heard it.
Okay. Alright, well, great job, Wonka.
One job.
One job. Alright, so it does speed up. How do you know? No, you need to stay there.
He's crying.
One cruise.
Hey, can you grab that lock post? Okay, put it where we're going to move our motion detector up here.
Good idea.
Since we can't do a great job of protecting it, you can just leave the lab post right here. Sorry, Alex.
I'm sorry.
It's okay. Alright. You can't hear Brandon. Do you want somebody else?
No, I got it.
Can you? Alright. Good. Let me just... Okay, I'm going to press collect again. Good. It's okay. Alright. So let me go here. I'm going to auto scale everything.
I'm just like watching all the chaos happen.
I know, they're not confused at all. Alright, so what do you notice is happening right here?
It has an exponential.
Is it?
Okay, so exponential. It's actually quadratic, but we're going to get there. It is increasing. But what do we notice about our velocity graph now? It's no longer a flat line, right? Okay, now it has a slope because instead of staying at a constant velocity, we are increasing our velocity. As our slope increased, because we have a curve now, our velocity also increased. Now, we moved the car to the right, so what's true about the slope of this graph? Okay, it's also positive. So right now, on your little guide, for the smaller incline, I want you to draw the position and time graph and the velocity and time. Yeah, don't let go yet. Here we have a higher incline, and we're going to collect all new data. Let me get rid of this. I don't know why it's asking me this after each thing. Alright, ready? Okay, when I wait for the text because it might come up with a question mark or a dialog box. Nope, go ahead. Very good. Let's do that again so we can isolate just this section. Ready, go. Oh, sorry, I went on go. It's not. See, Brandon's not the only one. I'm a bad leader at this, right?
I heard go. I'm a runner. When I hear go, I go.
He's a runner. There we go. All right. So here I did like a scale thing. Let's auto-scale both of these. We won't write the equations for these, but what do you notice once there's a steeper incline? What do you notice about the graph right here? It's still curving. It's hard to see.
I think it's still in the square. X squared. Is it?
There you go. What's different? Okay, it looks more linear because we only have data for a smaller time. But what? Okay, it has a massive jump in velocity. It's increasing its velocity so quickly we can't even get a nice curve there, okay? But it's still a quadratic function here because when I linearize this, if I put this against my time squared column, it looks a lot more linear right here. So we still have position is proportional to time squared instead of just time. So if we have a greater acceleration, then our graph ends up curving up even faster. All right. Same thing for our velocity. We could do a linear fit for some section right here. Let's do it maybe right here. Not sure what could have happened between this point and this point here to make it not be a linear velocity or linear acceleration or a constant acceleration. What could have happened to our car?
It would kind of push a little bit at the beginning.
Okay. No, not necessarily, but this isn't a perfect world, so because it's at such a high angle, where's my car? Right here. Because it is at such a high angle, it's just trying to collect data so fast that if at any point the tires got caught or wiggled at all, that could have added or taken away a little bit of force to cause its acceleration to change just a little bit. So we can look in the beginning, if we were to like do a linear fit over this, come on, over that section, we get an acceleration of 6 meters per second per second. Is that more than what we had before? For when it was a smaller incline? And then we could also do a linear fit for this section. Maybe. But it still should be more either way. So this acceleration tells us that's not a good acceleration, is it? 1.788. What was our acceleration before for the smaller incline? Okay, so it still increased. That's good. So either way, what you need to know is that your velocity and time graph, when you have a constant acceleration, it no longer has a slope of 0. The slope of this velocity and time graph gives you what? The value for your acceleration. Okay, the slope of a position and time graph tells you all about the velocity. The slope of a velocity and time graph tells you about the acceleration. Okay, are there any questions? You guys are getting ready to do a pretty intensive lab where you look at all the different ways an object can accelerate. Let's go ahead and I want somebody to take the car and push it up the ramp. This will mimic slowing down to the left. Okay, you can go ahead, Sam. Okay. Let me obviously listen for it to click. Don't listen to me. Okay. Give it a good push.
A little too hard.
A little too hard. That'll do, pig. That'll do. Go. Do it again. Epic fail. Can you give it just a little push? Little push. Ready? There we go. Oh!
Is it even reading it?
No, it's not.
Maybe.
Maybe from the force of the hits.
Yeah. You broke the reader.
I broke the reader. That is a problem. Try it again. Just for. Okay.
Okay, so it's working.
Okay, it's working now. You ready?
Middle push.
Just gonna let it do its thing. Okay, good. All right, so here we have where it was slowing down, right here at this section. So notice we have a steeper slope right here, and then here at the bottom, right here, what's happening? Yeah, it went from a negative velocity approaching a zero velocity, and then what happened is it came back down. It increased its slope, which meant it increased its speed. Very good. All right, now you get to play with all of this faulty technology.